Good morning. How are you today? According to the exam, the question about probability, you are concerned about all the pages. You will have in the exam an example similar to this. Choose simultaneously. You have a problem of 3 or 4 parts. Also, you will have a part of it choose successively. It is similar to these. And you will have till here conditional probability until this activity here, conditional probability till this activity. So to page 16. You have everything to page 16. You have, as I told you, you have similar to this example, choose simultaneously and choose successively. This one, this is very important, choose simultaneously and choose successively is very important. So good work for the exam. Now we'll continue solving exercise of problem 3. So part B, in problem 3, we have solved part A, now part B. An enterprise produces a certain product. An enterprise produces a certain product. The marginal cost of production is given by, this is given the marginal cost. Remember that the marginal cost is the derivative of the cost. Where X is expressed in hundreds of units, X in hundreds of units, and MC, the cost, is expressed in tens of thousands, 10,000s of Lebanese lira, well, X is between 0.5 and 25. Calculate the marginal cost of production of 500 units. So 500 units, we divide them by 500 because X is in hundreds, and we put MC of 5. So here, exercise 3, part B. X equal 500 over 100, so X equals 5. MC of 5 equal 10 plus 1 plus 1 over 5 equal 11.2 10,000s of Lebanese lira. So MC of 5, we multiply it by 10,000, we get 112,000 Lebanese lira. So the marginal cost of production, if you are told about the economical interpretation, if you are asked, so the cost of production of the 600th unit, because here MC of 5, we added 1, so the cost of production of the 600th unit is 112,000 Lebanese lira. But here you are not asked about the economical interpretation. In case you are asked, this is the answer. Now part B. Knowing that the cost of production of 100 units is 20,000 Lebanese lira. Show that the total cost function is this one. How to prove that the total cost function equal to this? We have to prove that the derivative of the cost equal the marginal cost, and we have to prove that the cost of production of 100 units is 20,000 Lebanese lira. So the cost of production of 100 units is 20,000, and the derivative of the cost is, now the derivative of the cost, the derivative of x squared is 2x, derivative of x is 1, derivative of ln x is 1 over x. So the derivative of the cost equal to the marginal cost. Now 100 units, in x equal 1, C of 1 equals 1 plus 1 plus ln 1. Ln 1 is 0 equal 2. 2 10,000 means 20,000 Lebanese lira. So here, Cx equal x squared plus x plus ln x. C prime x equals 2x plus 1 plus 1 over x. Derivative of ln x is 1 over x. So it is equal to MC of x. The derivative of the cost equal the marginal cost. C of 1 equal 1 plus 1 plus ln 1 equal 2 10,000 equal 20,000. So it is verified. It means that the total cost is given by this one. Part C. The unit price of each unit is 200 Lebanese lira. Suppose that the produced quantity is totally sold. Prove that the revenue function, this is not a question here. Part D, prove that the revenue function is given by Rx equals 2x. Revenue equals x times the unit, which is 100, times the price, which is 200 over 10,000, we will get 2x. So the revenue is given by this rule. Revenue Rx equal x times unit times the price over unit. Unit for the quantity is hundreds, x times 100 times the price of the unit is 200 over the unit price is 10,000. 4 zeros in the numerator, simplified with 4 zeros in the denominator, so we get 2x. Part E. The curve P below, the curve P to the right, is that of the profit function. For what value? What is the value of P of 1? P of 1 graphically is 0. P of 1 is 0. Give the economical interpretation. So if the profit is 0, no gain, no loss. No gain, no loss. Yani we have a break even for x equal 1, or the quantity is equal 100 units. So part E, P of 1 equals 0 graphically. For a production of 100 units, the profit is 0 in a break even. We have a break even or no gain, no loss. Now, part 2, for what values of x the enterprise experience a profit? For what values of x the enterprise experience profit? To experience a profit, it means profit is positive. The profit is positive from here, from 0 till 1. They are not included. But here, if the domain is 0.5 till 25, yani from 0.5 till 1. Part 2, we have x is between 0.5 and 2.5. This is x given. To realize a profit, Px should be positive. Graphically positive in x belongs to 0, 1. 0, 1. But 1 is not included. So x is between 0.5 and 1. So for a production between 500 units, between 50 units and 100 units, for a production of 100 and not 250 and 100 units, correct it please, 100 units, the enterprise experience a profit. For a production between 50 and 100 units, the enterprise experience a profit. Now we start with exercise problem 4. Problem 4. Part A. Let f be a function defined over minus infinity plus infinity by fx equals half e power 2x minus 2ex plus x plus 1.5. This is fx, domain minus infinity plus infinity, and denote by c its representative curve. Calculate the limit على minus infinity وعلى plus infinity. على minus infinity, e to the minus infinity 0, 0, we get minus infinity. على plus infinity, this one becomes plus infinity, minus infinity, plus infinity, indeterminate. So I take the highest power. The highest power is half e power 2x. As x tends to infinity, it will be plus infinity. So limit as x tends to minus infinity of fx. We replace each x by minus infinity, half e to the minus infinity, minus 2e to the minus infinity plus 1.5, e to the minus infinity is 0, we get minus infinity. Now limit as x tends to plus infinity of fx equals infinity, minus infinity, plus infinity, which is indeterminate. In this case, we take the highest power, which is half e power 2x. So limit as x tends to plus infinity of fx equal limit of the highest power, half e power 2x, which is plus infinity. Part 2a. Prove that the line D is, of equation y equal x plus 1.5 is an asymptote to C. To prove this line is an oblique asymptote, we have to prove that the limit of fx minus yd as x tends to minus infinity is 0. Limit fx minus yd is equal to 0 as x tends to minus infinity. So here fx minus yd, we get half e power 2x minus 2e to the x. Limit as x tends to minus infinity, let fx minus yd equal half e to the power minus infinity minus 2e to the minus infinity equal to 0. Since the limit as x tends to minus infinity, the fx minus yd is 0, we say that the line D of equation y equal x plus 1.5 is an oblique asymptote to C at minus infinity. Part B. The question is, study the position between C and D. To study the position between C and D, we have to study the sign of fx minus yd. Fx minus yd, half e power 2x minus 2e to the x. I take e to the x common, then remains half e to the x minus 2. E to the x is positive, I don't take it. So I have to solve fx minus yd equal to 0. I take the second part, half ex minus 2. Then half ex equals 2. I take minus 2 to the next side, it becomes 2. Cross multiplication, e to the x equal 4. To remove e, I put ln, so x equal ln 4. Now, the table of position, fx minus yd, I put domain minus infinity plus infinity, fx minus yd position. Ln 4, I put 0. To know the sign after ln 4, I take a number greater than ln 4, which is 2. If I replace it here, I get positive. Here is negative. At ln 4, it is 0. Negative, we say C is below D. Positive, C is above D. 0, D cuts C at ln 4. To find the intersection, I replace the value of ln 4 either in the equation of the line or in the function. So I get the point of intersection 1.3, 2.88. Part 3. Show that f prime x equal e to the x minus 1 squared and set up the table of variations. Derivative. Derivative e to the u. First, I make the derivative of the power. Derivative of 2x is 2. I multiply it by half. It becomes 1. 1e power 2x. Derivative of e to the x is e to the x minus 2e to the x plus 1. So don't forget the derivative of e to the u equals u prime e to the u. Derivative of e to the u is u prime e to the u. So here we are going to determine the derivative. Part 3. As I told you, derivative of e to the 2x, I make the derivative of the power. Derivative of 2x is 2. I multiply it by half times e power 2x minus derivative of e to the x is e to the x. Derivative of x is 1. Derivative of 1.5 is 0. 2 and 2. So it is e power 2x minus 2ex plus 1. It is equal e to the x minus 1 squared, which is greater than or equal to 0. Since it is square, so x, f prime x, fx, domain minus infinity plus infinity, positive, it is increasing from minus infinity to plus infinity. Here we have oblique asymptote. here tends to plus infinity. Now part 4, to draw the curve, it is required, part 4, trace D and C. To trace D, line D of equation y equal x plus 1.5 for x equal to 0, y equal 1.5, this is 1.5, for x equal minus 1.5, y equal to 0. This is the oblique asymptote. I draw the oblique asymptote, which is D. Now the point of intersection between the curve and the oblique asymptote is 1.3, 2.8. 1.3, 2.8. This point is 1.3, 2.8. I locate this point. For x equal to 0, y equal to 0. For x equal 0, if we replace x by 0, we get y equal to 0. So the curve will pass through the origin. Now you use your calculators by using mode table. You put the function, you take particular points. You can start from minus 4 till 4. The value which is too big, we don't take it. We take the small values. So here the curve is below the oblique asymptote, as we have seen. First, C is below the oblique asymptote. It passes through the origin. Then it increases. It cuts the line D here. And it goes to plus infinity. With the particular points, it will be more precise. Five, show that the equation fx equal 2 admits a unique solution alpha between 1.2 and 1.3. Graphically, this is fx equal 2. This is fx equal 2. This is y equal 2. Graphically, the line y equal 2 cuts C at one point. To verify this point between 1.2 and 1.3, I find f of 1.2 should be less than 2, and f of 1.3 should be greater than 2. One of them is less than 2, and one of them is greater than 2. So here we say f is continuous and strictly increasing. It is increasing all over. So it is strictly increasing over 1.2, 1.3. F of 1.2 is 1.57, which is less than 2. Pay attention here, we are solving fx equal to, not equal to 0. If it is equal to 0, one of them will be negative, one of them will be positive. Here fx equal to, one of them will be less than 2, and one of them should be greater than 2. So f of 1.3 equal 2.19, which is greater than 2. So fx equal to has one root, as you see it here. Fx equal 1, 2. Fx equal 2 has one root between 1.2, this is alpha here, between 1.2 and 1.3. Now, part B. An enterprise produces X objects of a certain product. The total cost function, this is the total cost function, is given as fx. It is the same as fx. X greater than or equal to 0, sure, the number of objects cannot be negative, so x greater than or equal to 0. X is in 10,000, x is in thousands of objects. X is in thousands of objects. And the cost is in millions of Lebanese lira. Always we have to pay attention for the unit of quantity and the unit for the cost. Each unit is sold for 1,000 Lebanese lira. Each unit is sold for 1,000 Lebanese lira. For what value of X, the cost is 2 millions. For what values? Or for what value of X, the cost is 2 million. The cost 2 millions, يعني 2 millions over 1 million, 2. يعني CT of X equal 2. I cannot solve it by calculation. I go back to part 1. C is fx, so fx equal 2, then x equal alpha. Then x equals alpha, which is between 1.2 and 1.3. I can take it in the middle, which is 1.25. Part B, so cost is 2 millions over 1 million equals 2. CTX equal 2, but C is the same as fx. So fx equal 2, then x equal alpha, which is 1.25 thousandths of objects. The alpha is given between 1.2 and 1.3. If alpha is not given, I can take it the midpoint. To find the midpoint, I add 1.2 plus 1.3 and I divide it by 2, I get 1.25. 1.25. Part 2, find the revenue function. Revenue is equal x times unit times the price over unit. So revenue Rx equal x times the unit here 1,000. The price is 1 million because he told us that each item is sold for 1,000. So 1,000 over 1 million, 6 zeros. With 6 zeros, we get x. So Rx equals x. Prove that the profit function is given by this one. Prove that the profit function, the profit, you know that the profit equal Rx minus Cx. Profit function equals Rx minus Cx. Rx is x minus Cx, this is minus half e power 2x plus 2e to the x minus x minus 1.5. X minus x 0 remains minus half e power 2x plus 2e to the x minus 1.5. It is difficult to factorize this expression, so I take the second part, minus half e to the x minus 1 into e to the x minus 3, and I expand. Minus half, I leave it minus half, I put the brackets, e to the x times e to the x, we add the powers, e power 2x, minus 3e to the x, minus e to the x, plus 3, minus half e power 2x, minus 3, minus 1, minus 4 times minus half, it will become plus 2e to the x. 3 times minus half is minus 1.5. So this is the profit function. This is the profit function, which is Rx minus Cx. Part 4, for what value or values of X will the company realizes a profit? The company realizes a profit. Okay, to find the values of X for which the company realizes a profit, so I solve Px equal, Px should be positive, Px should be positive. I first solve Px equal to 0. So minus half e to the x minus 1 into e to the x minus 3 equal to 0. Each factor equal to 0. E to the x minus 1 equal to 0 in e to the x equal 1. I take len on the two sides, x equal len 1, x equal to 0, which is rejected because we have x is positive. Now e to the x minus 3 equal to 0, the second factor. E to the x equal to 3, then x equal len 3. I make a sign table. Zero, len 3 plus infinity. So I can take a number between 0 and len 3, like 1, and I put it here. I will get here, if I take x1, which is e to the 1, which is positive here. Here it is negative times negative, we get positive. So here it is positive, here it is negative. So x is between 0 and len 3. Finally, the last part 5. For what value of x will the company realize a maximum profit? Find this maximum. Maximum, I have to make the derivative. So here, Px is equal minus half e power 2x plus 2e to the x minus 1.5. P prime x is 2 times, I did 2, I multiplied by minus half, it's here minus e power 2x plus 2e to the power x. E to the power x common minus e to the x plus 2. P prime x equal to 0. E to the x is positive, I don't take it. minus EX plus 2 equal to 0 means EX equal 2. It means that X equals ln 2. X equals ln 2. I put ln 2. A value which is greater than ln 2, like 1. Here it will be negative, positive. Increasing, decreasing. For X equals ln 2, Px is maximum. And the maximum profit is 0.5 millions of Lebanese lira. This is all about this exercise. I have sent you the solution of the remaining exercises. You can solve them as a practice. Study well, depend on yourself. See you.